Maybe you know. Science meets the questions you never thought to ask. On the night of October 19th, 2017, a postdoc named Robert Warrick was sitting in front of a laptop in Hawaii, scrolling through telescope frames from the night before. He stopped on one image, a faint smudge of light, moving too fast. Too fast for a comet. Too fast for an asteroid. Too fast for anything that belonged to our solar system. He checked the trajectory 3 times. Then he picked up the phone. For decades, astronomers had a question they couldn't answer. When stars die, they fling debris into the galaxy. Comets, rocks, frozen lumps of nothing. Billions of them. So statistically, the Milky Way should be full of interstellar visitors drifting between the stars, occasionally passing through other solar systems. Our own. The math said one should slip through our neighborhood roughly every year. Karen Meach, an astronomer at the University of Hawaii, had spent her career hunting for them. She'd written models. She'd searched archives. Nothing. Every comet, every asteroid, every chunk of rock ever spotted came from inside our sun's gravitational family. Some looped out to the Oort cloud, some hugged Jupiter, but they all belonged here. They were born here. So either the models were wrong, or we were missing something. Maybe the visitors moved too fast. Maybe they were too dim. Maybe they were too small. Or maybe, and this was the unsettling option, there was something about our solar system that made it almost impossible to catch one. For 60 years, the question sat there. Then in October 2017, a single line of data on a hard drive in Hawaii cracked it open. The telescope was called Pan, Stars 1, a 1.8-meter mirror perched at 10,000 feet on the Haleakala volcano on Maui. Its job was to scan the entire sky every few nights, looking for things that move. Asteroids, mostly. Things that might one day hit us. On October 19th, it caught something. Robert Warrick, a Canadian postdoc, was the one who flagged it. He noticed the dot was traveling at 26 kilometers per second relative to the sun, far above the escape velocity. Whatever it was, the sun couldn't hold it. It was just passing through. Within 48 hours, observatories from Chile to the Canary Islands were tracking it. The European Southern Observatory's very large telescope. NASA's Spitzer. Hubble. They had a deadline. By December, the object would be too far and too dim to study. They named it Oumuamua, Hawaiian for a messenger from afar arriving first. Karen Meach, the astronomer who'd been hunting these things for decades, finally had one in her sights. And then, when the data started rolling in from those 11 days of frantic observation, every single thing they thought they knew about interstellar objects fell apart. Start with the shape. Most asteroids are lumpy, roughly round, potato-shaped if you squint. Oumuamua wasn't. As it tumbled through space, its brightness swung up and down by a factor of 10, meaning one side was 10 times bigger than the other. Imagine watching a pencil spinning in the air from far away. Bright when the side faces you, dim when the tip points at you. That's what astronomers were seeing. The object was somewhere between 100 and 400 meters long, but only 35 meters wide. A ratio of roughly 10 to 1. We had never seen anything like it in our solar system. Then there was the color. Deep red. A reddish tint usually means the surface has been baked by cosmic radiation for hundreds of millions of years. So Oumuamua was old. Very old. Possibly older than the sun itself. There was no tail. No coma. No gas. No dust streaming behind it like a normal comet. It just looked like a dark, dry, frozen splinter. And then it did something it had no business doing. As it swung around the sun and started heading back out, it sped up. This is where the story breaks. Gravity is rules. When an object passes a star, gravity bends its path and changes its speed in completely predictable ways. We can calculate the trajectory of a comet 100 years in advance, down to the second. Oumuamua refused to follow the math. By the time it crossed Earth's orbit on its way out, it was moving slightly faster than gravity alone could explain. Not by much, about 0.1%. But in physics, 0.1% is a screaming alarm. Something was pushing it. Comets do this. When ice on a comet's surface heats up and evaporates, it shoots out gas like a tiny rocket engine. That's what gives comets their tails. So astronomers looked. They looked at every wavelength. Hubble looked. The Spitzer infrared telescope looked. They expected to see at least a faint puff of water vapor carbon dioxide, methane, anything. There was nothing. No gas. No dust. No tal. Whatever was pushing Oumuamua, it was invisible. A push without a plume. A rocket without an exhaust. And nobody on Earth could explain how. In 2018, a team led by Marco Micheli at the European Space Agency published a measurement that turned the puzzle into a crisis. Using over 200 observations from the Canada-France-Hawaii telescope, Hubble, and the Very Large Telescope, they nailed down the anomalous acceleration to 1 part in 1,000 of the Sun's gravitational pull. Real. Statistically airtight. The paper landed in the journal Nature on June 27, 2018, and it ended with a sentence that sent astronomers spiraling. They could find no explanation that fit all the data. Then in 2021, Stephen Desch and Alan Jackson at Arizona State University proposed a wild idea. What if Oumuamua was a chunk of solid nitrogen ice, ripped off the surface of a Pluto-like world in another solar system? Nitrogen ice would sublimate invisibly. It would push the rock without leaving a tail. And nitrogen reflects light in roughly the right way. The model worked mathematically. 2 years later, in March 2023, Jennifer Bergner and Daryl Seligman ran another simulation. Their answer, molecular hydrogen, frozen inside the rock, slowly leaking out under sunlight. Also invisible. Also a perfect fit. 2 theories, both elegant, both unprovable, because Oumuamua was already gone. And then there was Avi Loeb. The chair of Harvard's astronomy department doesn't say outrageous things lightly. But in November 2018, Loeb co-authored a paper that proposed a different explanation. What if Oumuamua wasn't natural? What if it was a piece of alien technology? A light sail. A thin, flat sheet of material designed to be pushed by starlight. That would explain the strange shape, not a cigar, but a disk. It would explain the acceleration. Sunlight itself was the engine, no exhaust needed. It would even explain the color. Loeb wasn't joking. He'd done the math. The sunlight reflecting off Oumuamua, given its size and brightness, could produce exactly the push astronomers measured if the object was less than a millimeter thick. Most astronomers hated it. They called it sensational, unscientific. Loeb wrote back, calmly, in a book titled Extraterrestrial in 2021, that ruling out an explanation just because it's uncomfortable isn't science. It's faith. And here's the part nobody likes to say out loud. Even the natural explanations require materials we've never observed in nature. Nitrogen icebergs. Pure hydrogen ice. Whatever pushed Oumuamua, it was something humans had never seen before. Here's what makes it worse. Oumuamua wasn't a fluke. In August 2019, a Crimean amateur named Gennady Borisov spotted a second interstellar object, a comet, this time, with a clear tail and ordinary chemistry. It went, no mysteries. So nature can do it the boring way, which means Oumuamua chose to be weird. And the new generation of telescopes is about to start finding them at a terrifying rate. The Veracee Rubin Observatory in Chile begins full operations in 2025. It will scan the entire visible sky every 3 nights with a 3.2 billion pixel camera, the largest digital camera ever built. Predictions say it should discover 1 new interstellar object per year. Maybe more. Some of them will be boring rocks. Some will be comets like Borisov. But statistically, one of them eventually will be another Oumuamua. Something old. Something wrong-shaped. Something that breaks the rules. And next time, we'll be ready. There are already mission proposals. Project Lyra, from the Initiative for Interstellar Studies, designed to chase down the next interstellar visitor with a probe and actually photograph it. If they pull it off, we will finally know what we missed. 11 days. That's all we had. From the moment Robert Werik circled a fast-moving dot on a screen in Hawaii to the moment Oumuamua slipped past the orbit of Mars and faded into the dark, we got 11 days with a piece of another star system. A splinter of red rock, older than our sun, tumbling end over end, accelerating in a way nothing should. We measured it. We photographed it. We wrote papers. We argued. And then it was gone, on a trajectory heading toward the constellation Pegasus, where it will drift for another 100 million years before passing close to another star. Maybe it's a fragment of a dead world. Maybe it's hydrogen ice. Maybe it's something stranger. The real answer is sitting out there in the dark between the stars, waiting for the next one to arrive. Next week, Voyager 1, the probe that left Earth in 1977, crossed into interstellar space in 2012 and started sending back impossible data in 2023. The plasma readings don't match the models. The magnetic field is doing something nobody predicted. NASA engineers are working with code older than most of their interns, and the probe is still talking from 24 billion kilometers away. Subscribe so you don't miss what it told us. Thanks for watching. If this sparked a question, drop it in the comments. It might be your next video. We'll see you next time.